Okay, so first off, we're going to continue lecture 1. You have your note sheet, right? So if you don't have your note sheet, go print one right now, pause the video, go to Google Classroom, print a new one. That way you can fill it out as we go. You will also need a periodic table and probably a calculator because we're going to get into some of the sample problems. So when I come back, or when we come back from break, I'm going to check the notes in the sample problems. So have all those caught up for the Monday we come back from Thanksgiving break. All right, so let's dive in. So continuing our study about moles and counting and things like that for chemistry, let's have a brief review of what the periodic table tells us, because this is super helpful. We've been focusing on the backside of the periodic table for the ions. Now we're going to focus on what the actual symbol and numbers tell us in the periodic table. So for looking at carbon, for example, you have 6 and 12. I know that the periodic tables have decimals. We'll be rounding those to whole numbers just to make the math easier. And I round all of the elements except for 2 of them, copper and chlorine. I keep a 0.5. If you absolutely hate that, feel free to use the decimals. It's not going to change the overall answer to something I won't understand for your homework or your quiz. All right, so this top number, that is the atomic number. That's how many protons this element has. Okay, if we change the atomic number, we're changing the element that we're dealing with. This is the element symbol. That's how we figure it out. Remember, all the elements have either an uppercase letter, and that's it, or they have an uppercase and a lowercase. So that's how you can tell if it's chlorine or carbon and iodine. Trying to figure out the capital L or the capital I versus the lowercase l. And then this bottom number is the atomic mass, or otherwise known as the molar mass. And what it tells us is this new thing we're studying. It's how many grams it takes of that element to make up 1 mole of that element. Okay. This means that 1 mole of carbon would have a mass of 12 grams. So if I had a vial of carbon in my chemical storage and I wanted to see what a mole of it looked like, I would just grab the scale and I would measure out 12 grams of this powdered carbon compound. And that would be what 1 mole looks like. Okay. So remember, 1 mole is 6.02 times 10 to the 23rd atoms of carbon. So it would be impossible to count out that number, 6.02 times 10 to the 23rd. That's going to be impossible to count out. But I can use the scale and easily measure out 12 grams. Okay, so that's how the numbers on the periodic table for the atomic mass and the molar mass help us do our calculations. Okay, so let's do a couple sample problems. So knowing that 12 grams of carbon is equal to 1 mole of carbon, which is equal to 6.02 times 10 to the 23rd atoms of carbon, these are all of our equivalencies. So what happens if I double those numbers? Make sure you also remember how to enter the times 10 to the 23rd on your calculator correctly. That's going to be using the EE or EXP button. The classroom calculators, it's the EE button. And then you just enter EE 23. You don't type the 10 or the X, okay, the times. So if we double the moles, say I want 2 moles of carbon, that's going to automatically give us a doubling of the grams, so from 12 to 24, and it's going to double the number of atoms, 1.2 times 10 to the 24th atoms, okay? So these are all just equivalencies. This unit will be really easy if you just keep track of your units, and remember that to cancel out a unit, you need the same thing on top and bottom of your equation. Okay. So I'm going to do the first 2 sample problems, and then you're going to do number 3 on your own. Okay. So starting at the top, how many moles of iron are in 38 grams of iron? All right. So the first thing we do is we're given 38 grams of iron. This is what we are given to start with. So we're going to start by putting that down just to go. All right, grams, iron. And then we're going to do our times in a line. And now we're going to go to the periodic table and we're going to look up what is the atomic mass for iron, all right? And what you're going to see is that 56 grams of iron is the same as 1 mole of iron. That's the molar mass. So once you know this equivalency, you can decide what's going to go on top and what's going to go on bottom. We have grams of iron on top, so we need to have grams of iron on the bottom. So 56 is going to go on the bottom, and 1 mole is going to go on the top. And what that does is it cancels out the grams of iron, leaving us with moles of iron. And then the math is 38 times 1, you don't have to do that, divided by 56. And that leaves us with a final answer of 0.68 moles of iron. Okay. Same thing for how many atoms of copper are in 5 moles. So now we're doing a little bit of the opposite. We're starting with 5 moles of copper. So we write down 5 moles of copper. We are going to not need our periodic table for this one because it's looking for atoms. And I know, and so should you, that 1 mole is equal to 6.02 times 10 to the 23rd atoms. It's like the same as saying a dozen, right? Except it's a mole. So in our 5 moles of copper, we do our times in a line. And we use our equivalency. 1 mole is the same as this number, 6.02, 10 to the 23rd atoms. And now you decide what's going to go on top and what's going to go on bottom. So 5 moles of copper tells us we need to have moles here on the bottom. So we're going to put 1 mole on the bottom. And Avogadro's number, 6.02 times 10 to the 23rd atoms of copper on top. And then the math of this is you're going to take 5 times 6.02, and remember you're going to do E. That takes the place of all of that. So 6.02 EE23, multiply that by 5, and get your answer. Oh, sorry, glitching here. Of 3.0 times 10 to the 24th atoms of copper. Okay, so for number 3, very similar. Start with what you were given, and you're given 2,000 atoms of iron. Write down your given, times in a line, and then you're going to go back and use this equivalency to figure out what goes on top, what goes on bottom, and come up with your answer for how many moles of iron you will have. This will be an incredibly small number. Okay, so if you don't get a negative exponent, definitely like shoot me an email or something so we can talk about like what happened on that one. Okay, so you can pause the video, finish that one, and then come back, and I'm going to move on to the next one, which is molar mass for compounds. Okay, so far we've been doing atoms. So the atomic mass for elements, we've been doing elements, and the atomic mass for that is very easy. You just look it up on the periodic table. So the molar mass or molecular weight for a compound is just as easy. It just takes up all of the masses of the elements that make up the compound. So I have a method I like to show where I draw a line down from each element, and write the amount of that element, like the quantity, multiplied by the mass of that element, and then I add it up. So it looks like this for when I'm doing it. If you have a different method, that's fine. Just make sure you're keeping track of all of the atoms, elements in your compound. So for example, if we look at water, this is just 2 elements. So I'm going to draw a line down from hydrogen and over, and a line down from oxygen and over. And then I'm going to write down how many hydrogens I have. And in this case, I have 2, and the molar mass of hydrogen is 1. And then I'm going to write down how many oxygens I have. I have 1 oxygen, and its molar mass is 16. And then I simply add up 2 and 16, okay, add these together to get 18 grams of water is equal to 1 mole of water, okay? So individual elements, the amount of that element in your compound, so the 2 there, this is the molar mass from the periodic table, okay? Multiply them, get your total, and then add them up, and that gives you your amount of molar mass for that compound, okay? So another one, calcium calcium carbide, sorry. 1 line down and over for calcium, 1 line down and over for carbon. How many calciums are there? A single calcium, so go look at your periodic table. And calcium's a 39 point something, so we're going to round that up to 40. So 1 times 40 is 40. How many carbons are there? 2. And carbon is 12. So 2 times 12 is 24. So we add 24 and 40 together and get a molar mass of 64 grams of calcium carbide is in 1 mole of calcium carbide. Okay? All right, so let me introduce you to your new best friend in chemistry. This is the mole road map. I put a copy of it in the Google Classroom. If you want to print off Classroom, you can print it off and have it as just a part of your notes, or you can look at it digitally. You will want a printed copy for this unit quiz, I'm sure. So what is this? It is just a way to navigate conversions, okay? It's just a tool. It's 100% based on factor labeling or unit conversions. It works with starting with what you have, you're given, and then you travel to what you want using the conversions listed, okay? Now, so far, we've not dealt with volume, all right? So you can ignore this arm of the road. We'll come to that one after break. Right now, though, we have done mass, which is grams, and we've done representative particles, which are atoms or molecules. So if you're going from mass to moles, this shows, hey, guess what? This is what your conversion factor looks like, because it puts atomic mass on the bottom and grams cancel. If you're in moles and you want to go to mass, notice how these two things are just flip-flopped, okay? Same thing if you want to go from moles to particles, it's Avogadro's number over 1 mole. Or if you're in particles and want to go to moles, it's just flip-flop. It's just a tool, folks. If you look at this and you're like, I hate this, that's fine. Just keep track of your numbers and remember to cancel things out. You have to have the same unit on top as you do on bottom. Okay, it's really quite easy. All right, let's dive in. So the rest of Lecture 1 notes consists of... we got some practice problems that I'm going to help. Oh, well, okay, Lecture 1. So we've got 9 practice problems. Consider this your schoolwork / homework, and I will check these when we come back from break. Okay, so have them done by then. And if you have any issues, just send me an email. What I will do here at the end of the lecture is I will write out the answers to the questions, but not in order. So I call them scrambled answers, and that way you can check your work. So if you do a problem and you get a number on the list, you probably did it right. If you do your work and you don't have a number anywhere close to one on the list, then there's a problem, all right? But I like to do that so that if you're doing work independently, you know if you're at least in the right range, okay? So I'm going to do 3 of the 9 problems to give you just some practice, guided practice, and then you can work on the rest by yourself. You can also ask Jim questions. I gave him an answer key so he can check your work as well. Okay, so first one, calculate the molecular weights of these compounds. So the first thing I'm going to do is, I think the blue is pretty easy to see. I draw a line down and over for each element in my compound. Okay, Then I write down the fact that I have 2 hydrogens, 1 sulfur, and 4 oxygens. Okay, now I go to the periodic table and I get the mass for each element. Hydrogen's a 1. 2 times 1 is 2. Sulfur is a 32. 1 times 32 is 32. And oxygen is 16. 4 times 16 gives you 64. And then we're going to add up these. So 2 plus 32 plus 64 gives us a grand total of 98. Don't just write the number. You have to include the label. 98 grams per mole. All right, that is your final answer. That is the molecular weight, the molar mass of H2SO4, sulfuric acid. Okay, take a second, digest that information. And I'll do one with parentheses, so you have an example of that. All right, over here, line down and over for nitrogen, down and over for hydrogen, down and over for phosphorus. Okay, you have to pay attention to the number outside the parentheses. That gets multiplied into this compound. So this 3 gets multiplied here and here, okay? So that gives us a grand total of 3 nitrogens. Hydrogen has a 4 on the inside and a 3 on the outside, so you have to multiply those together. So I get 12 hydrogens and then only 1 of the phosphorus. All right, go to the periodic table, look up the mass of nitrogen, and it's 14. And 3 times 14 is 42. Hydrogen's easy, it's 1. 12 times 1 is 12. And phosphorus, we're going to round that up to a 31. And 1 times 31 is 31. Add up these 3 numbers for a grand total of 85 grams per mole. And that's your final answer. I'll circle these. Okay. So when you're doing the molar masses for the other 2, same thing. Just pay attention to the parentheses. Remember, it multiplies into every every element inside. And just keep track of your numbers. So once you get past the first 4 problems, now you have to do more than one thing, okay? You may also need to find the molar mass to start, which you will when there is a compound and you're trying to get to mass or moles. And you're doing a conversion on the roadmap, okay? So I'm skipping to number 8. So flip your paper over and go to number 8, where it says that you have 20 grams of SO3 is equal to how many moles? So before I write anything down, let's look at our roadmap. 20 grams puts us solidly in the mass circle. How many moles says we want to go here? So our roadmap says just go up, and this is your conversion factor. So I have to start by finding the atomic mass of this compound. Okay, so I'm going to start with SO3. I have 1 sulfur, 3 oxygens. I go to my periodic table, and sulfur is a 32. And oxygen's a 16. And 3 times 16 gives me 48. And we add these together, and I get a total of 80 grams per mole. That's my atomic or molar mass. Okay, I have to have that to start because that is part of the conversion factor here. Now I'm going to do my actual conversion. So I'm going to write down what I have to start with. So I'll use purple for this. So I've got 20 grams of SO3 times and a line. This is my conversion factor. Okay, and if you look at the roadmap going up, it says you want 1 mole on top and the atomic mass on bottom. And if you hate this, just look at your labels. I've got grams on top, so I need grams to be on bottom, which means the 80 goes on the bottom. And the 1 mole, what I want, goes on top. Okay? So the math of this is just 20 times 1, get an answer, divide by 80, hit enter, and you end up with a grand total of 0.25 moles of SO3. Like that. Okay? So that gives you plenty of time to finish the sample problems. I will, let's see, clear this out. Wonder if I can add a slide. If I go back, it's probably going to show everything. Yep. I would like to give you I don't think I have a blank page on here. All right, I'll write it on this one. These are going to be your scrambled answers. So scrambled answers for lecture 1. Practice problems. All right, I try to write them in smallest to largest. So let me just do a quick look-see through my notes here. I'm going to include all of them, even the 3 we've already done. All right, so that you have them in case you didn't pay attention to that part. So our smallest answer is 0.25. I'm not putting labels on these, so you can't just guess about which one goes where. Next biggest answer, 0.56. And then we jump up into bigger. So I just got to look through, make sure I'm not skipping one. 3.16. Okay. And then we go 78, 85, 98, 158, 664, and 1.2 times 10 to the 24th. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, there you go. Those are your scrambled answers. So we've already used 2 of them, right? We've already done that one and that one. And on the back side, we've done that one. All right. So you should be able to solve the problems and get answers that are close to this. Remember, I am rounding my periodic table masses to whole numbers, except for copper, Cu, and chlorine, Cl. Keep 0.5 in the mass. If you're using the whole decimal listed, then your answers will be close enough to these. You should be able to figure it out. All right, folks, have a lovely day, afternoon bowling, and a fabulous Thanksgiving break. I'll see some of you in Zoom conferences on Monday and Tuesday. All right, thanks a lot.